Welcome again to this webinar on the topic of electricity and electricity-related updates for the version 3.9 of the ecoinvent database. My name is Johannes and I'm a data analyst here at ecoinvent. In the webinar, all participants are muted. You can post questions in the dedicated question tab during all times in the webinar. We have reserved time at the end of the webinar for a Q&A session. Questions that we cannot answer on the spot will be followed up via email after the webinar. This webinar is being recorded and will be available on our YouTube channel. Also, slides will be shared after the webinar with all attendees. You will also receive a feedback survey, which we kindly ask you to fill out. If you're interested in further updates for version 3.9, please consider joining the upcoming webinar on the updates in the oil and gas sector. In this webinar, we will focus on the updates performed and implemented for the recently released version 3.9 of the ecoinvent database. We will talk about the yearly updates for the electricity sector and explain more about version 3.9's unique updates. Already in spring, we held a webinar titled Introduction to the Electricity Sector and the Use of ecoinvent Data for GHG Reporting. This webinar explained the structure and general modeling of the electricity sector in the ecoinvent database. Apart from a shorter refresher, I will not go into detail about the modeling of the electricity sector, but focus on changes done for version 3.9. If you're interested and have not seen it yet, I invite you to check out the Introduction to the Electricity webinar on our YouTube channel through the link provided on the slides. There will be 6 topics discussed in this webinar. At first, I will explain the yearly updates we perform for most of the electricity markets in the database. Second, we will introduce new high-voltage transmission datasets as well as individual transmission infrastructure amounts. The Swiss electricity markets as well as their transmission and transformation datasets were updated. We created update procedures for Brazil, China, and India, which were previously excluded from regular updates. For the first time ever, we add datasets on residual mixes to the attributional system models. And lastly, we received an update for datasets on cadmium telluride photovoltaic laminates. However, before we jump into the first topic, I would like to refresh your memory or introduce you to the general structure of ecoinvent electricity markets. Electricity markets exist on 3 voltage levels, high, medium, and low voltage, here shown in blue. There are electricity markets for practically all countries in the ecoinvent database, as well as for some special geographies. The different markets, usually delivering 1 kWh of electricity, also include direct emissions such as N2O, ozone, and SF6, as well as inputs for transmission and transformation infrastructure. Transmission losses are also included on all voltage levels. The electricity market datasets are fed by electricity producing activities, like nuclear, hard coal, or natural gas, for example, on the high voltage level, municipal waste incineration on the medium voltage level, and photovoltaic on the low voltage level. These markets themselves deliver electricity on their corresponding voltage levels for all demanding activities, and the markets are linked through transformation datasets that also include losses to transform from voltage to voltage. Electricity transmission from country to country happens on the high voltage level as indicated here. With this, we jump into the first topic of the updates for version 3.9, which concerns the yearly update we perform to the aforementioned electricity markets. All in all, the ecoinvent database contains high, medium, and low voltage markets for 142 countries. Since version 3.6 that was published in 2019, almost all electricity markets of the attributional system models, which includes cutoff, APOS, and since 2021 also EN15804, were updated on a yearly basis. However, there are some exceptions to the yearly update. The markets for Switzerland, Brazil, China, and India are not covered by this standard procedure. The Swiss market has to be updated through different data sources, as we will explore later. Brazil, China, and India are split into subgrids due to the size of their countries. For these geographies, individual update procedures were generated based on national statistics. In the regular electricity update procedure, the market shares, meaning which electricity production datasets feed into the market, for example, 30% coal, 20% nuclear, or 20% hydro, the production volumes as well as the overall transmission losses are updated. In this slide, you will see a short schematic of how statistics are integrated in the ecoinvent database. Starting from basic production and generation data on the national level, here for an arbitrary fuel mix with categories as they are common in electricity statistics. These categories are mapped to specific electricity production datasets as exist in ecoinvent. The electricity production datasets are modeled for specific production technologies such as electricity from hard coal and lignite, or for nuclear from boiling water reactor and pressure water reactor, or different types of hydro and photovoltaic. Information on imports and exports are added, and the corresponding amounts of the different technologies are distributed to the electricity markets. The markets are all scaled to deliver 1 kilowatt-hour of electricity, while they demand slightly more from the producing activities due to losses, which are introduced on the market level as well as for the transformation between the levels, here marked with an X. For this yearly update procedure, multiple sources are consulted. For production and generation data for OECD and non-OECD countries, imports and exports, as well as transmission losses, the extended World Energy Balance Statistics package from the International Energy Agency is used. For the US subgrids, data of the eGrid database is consulted, and Canadian regional production data is sourced from StatCan. For version 3.9 of the ecoinvent database, the IEA statistics deliver market shares and data for the year 2019 from eGrid, and StatCan data from 2020 was available at the date of data assembly. Supplementing the overall electricity markets, we updated datasets and values for high voltage transmission datasets. The University of Pforzheim provided us with datasets based on the shown publication here. As opposed to the previous high voltage transformation datasets, these new datasets model aerial, underground, and subsea cables. Before, only aerial transmission was modeled in the high voltage markets. The datasets themselves are accompanied by maintenance datasets, and they are modeled in Europe as well as for global datasets. These new datasets were introduced in all high-voltage electricity markets except Switzerland and Canada, Quebec, which kept their datasets based on studies from their own countries. Accompanying the change of transmission in the high-voltage markets, we also introduced country-specific transmission and infrastructure amounts. Data was collected from the Global Electricity Transmission Database. The database contains information on transmission infrastructure as well as technology splits for aerial, underground, and subsea cables. For the transmission infrastructure, a lifetime of 40 years was assumed, and together with the country's produced electricity, the amount of infrastructure per delivered kilowatt-hour of electricity was determined for all the electricity markets. So in the database, here through an example in EcoQuery, these new transmission activities look like this. For a high voltage market in France, for example, we now have 3 inputs of transmission, aerial, underground, and subsea, with corresponding amounts of infrastructure used for the delivery of 1 kilowatt-hour of electricity. From the global transmission report, data for almost 100 countries was extracted. For the remaining countries, we extrapolated from the existing data, and for these geographies, the assumptions that were made are recorded in the transmission exchanges in the market datasets. The change to new transmission datasets and country-specific infrastructure amounts had only minor impacts on LCIA scores due to the already small contribution of infrastructure to the overall LCIA score results of the electricity markets. As mentioned in the introduction, Switzerland is not updated with the same procedure as the majority of electricity markets. In the next couple of slides, we will explore how this update is performed. The market shares of the electricity market in Switzerland were updated to the year 2020. The market mix itself is based on the supplier mix Lieferantenmix in German, which is published every year under the shown URL. In order to map the fuel classifications of the supply mix to ecoinvent datasets, the data is supplemented by statistics by the Swiss Federal Office of Energy with their Gesamtenergiestatistik and Elektrizitätsstatistics. Data on wind power is accessed through winddata.ch and data for small-scale hydropower from Swiss smallscalehydro.ch. Next to the normal electricity markets, the ecoinvent database also contains a market for renewable energy products for Switzerland. This market summarizes all certified renewable electricity sold into a specific mix. Data is taken from the Association of Environmentally Friendly Energy from their report on renewable energy products in Switzerland. Although the procedure for the update is different, the Swiss electricity market is also updated on a yearly basis for all upcoming versions of the database. Complementing the market update, we also added new transmission and distribution data for high, medium, and low voltage levels for Switzerland. The inventories were extracted from the listed source and yielded new datasets for the transmission network construction on the high and medium voltage level, as well as for the distribution network construction dataset on the low voltage level. Next to Switzerland, special treatment was also required for the countries of Brazil, China, and India. Up to version 3.9 of the ecoinvent database, the geographies of Brazil, China, and India were not updated on a regular basis. These countries are split into subgrids due to their size, and our standard update procedure has no data available to update these subgrids. However, from this year onward, we will regularly update also the market mixes of these countries. The Brazilian electricity markets were updated to represent the year 2020. The market shares were collected and assembled by ACV Brazil. The sources used for the according data are listed on this and the next slide. Generation and loss data were both extracted from the Energy Research Enterprise in Brazil. Transmission between regions came from the electricity systems operator and imports from neighboring countries from their Energy Information System portal. Due to the format and segmentation of the Brazilian statistics used for this update, we were forced to merge 2 of the 5 regions in Brazil. The southeastern and midwestern grid were merged into a common geography called Brazil Southeastern/Midwestern Grid. The markets for Brazil Midwestern and Brazil Southeastern Grid were removed together with their accompanying datasets. Moving on to China, we also exchanged the resolution of the geographies. However, in this case, the State Grid Corporation of China, short SGCC geography, was split into its 6 encompassing subgrids. This allows for a better representation of local conditions. New electricity markets on all voltage levels, as well as transformation datasets, were created for these new regions. The SGCC region continues to exist as a market group for electricity on all 3 voltage levels, in which all the new markets are combined with shares according to their production volume. All in all, this leads to China being split into 7 subgrids together with the CSG region. And on this map, you can see the 2 geographies and which parts of China they contain up to the version 3.8. And for 3.9, the red SGCC region is split up into the shown 6 subgrids. Data for the update of China was collected for the year 2020 as well, and taken from the following sources. The sources yielded fuel categories split into thermal, nuclear, hydro, wind, and solar, and these categories were split into ecoinvent technologies based on information from Platts World Electric Power Plant database. Technology splits for wind are based on the windpower.net, and imports between the different regions are based on information on the listed paper here. Unfortunately, the original statistic on electricity exchanges was not directly accessible. Last of the special cases, we also updated the 5 subgrids of India. Due to the definition of a fiscal year in India, the data represents the period of the 1st of April 2019 until the 31st of March. We used the following data listed on this slide for parts of the update. Generation data and transmission losses came from the General Review 2021, published by the Central Electricity Authority. For technology mapping, again, the World Power Plant database was used. Interregional exchanges are included in the last monthly performance report of the fiscal year, which is March, as mentioned earlier. Wind technology is also based on the windpower.net. And for hydropower plants, there was no direct way to assess the corresponding types of power plants, so individual research for each Indian hydropower plant was conducted. At this point, I would like to mention some key takeaways from the first 4 updates we presented in this webinar. Up to this point, we have presented the regular update path for most of the electricity markets, as well as the specific update procedures for the missing geographies. This means from version 3.9 onwards, all ecoinvent electricity markets will receive regular yearly updates. All ecoinvent electricity markets together cover 100% of statistically represented global electricity production, and electricity markets now use updated country-specific amounts for high-voltage transmission infrastructure. For the next topic, we will move away from regular electricity markets and into the introduction of residual mixes into the ecoinvent database. I will first present a short introduction into the concept of residual mixes and then more on their implementation in ecoinvent. The shortest summary on residual mixes I could find is the printed sentence here. The residual mix is a virtual mix. It represents the energy mix of untracked consumption, in other words, electricity consumption that is not explicitly tracked through mechanisms such as guarantees of origin, also short GOs. Or in different words, the electricity mix represents the residual mix represents the electricity mix in a country where no information on the origin of the electricity is available. However, I will explain the concept of residual mixes a bit more in detail in the next slide. Should you be interested in the whole methodology, I can recommend reading the methodology by Grexel, linked below, and to watch the webinar by AIB, also linked on this slide. A residual mix of a country is calculated by first determining its domestic residual mix. The domestic residual mix is a concept that represents the electricity in a country after all electricity that was sold via tracking mechanisms was subtracted. This remaining mix has a volume of a certain amount of electricity equal to the electricity produced minus electricity sold. This volume is compared to the volume of how much untracked electricity, meaning electricity with no information on its origin, is consumed in a country. This difference defines whether a country is a surplus or a deficit country. It is a surplus country when the volume of the domestic residual mix is larger than the volume of untracked consumption. And vice versa, a country is a deficit country when the volume of domestic residual mix is smaller than the volume of untracked consumption. Together, all surplus countries in the area of calculation, which in this case covers all EU member states as well as Iceland, Norway, Serbia, and Switzerland, contribute their surplus electricity to the European attribute mix, also short EAM. They contribute that electricity in the same proportion between the different generation technologies as in their own mix. The EAM can be imagined as a melting or collecting pot of all surplus electricity of all countries in the calculation area. Its primary function is to redistribute the electricity imbalance created by the selling of guarantees of origin. The European attribute mix is then used as a source of electricity to fill up all deficit countries. After this redistribution, meaning after adding and feeding from the European attribute mix, the residual mix of a country is called the final residual mix. In this slide, we will quickly explore these concepts of surplus and deficit countries on two examples. A surplus country like Germany could produce the given and simplified mix of electricity with a volume of 313 terawatt-hours. However, its untracked consumption is only 190 terawatt-hours. This means it has to contribute 123 terawatt-hours of electricity in the same ratio as its production to the European attribute mix. In the end, it is left with the same mix, however, of a smaller volume. In this case, the mix between domestic and final residual mix does not change. In the case of a deficit country like Norway, it is left with a domestic residual mix of only 10 terawatt-hours after selling most of its hydropower through GOs. However, the volume of untracked consumption of the country is as high as 106 terawatt-hours. The missing 96 terawatt-hours are now filled up with the mix made up by all countries contributing to the European attribute mix. This leaves us with a final residual mix that has a very different composition than the domestic residual mix and is far more impactful than the initial mix. For the implementation in ecoinvent, the residual mix is calculated by the Association of Issuing Bodies, short AIB, were consulted. The fuel categories from AIB, shown here on the slide, were mapped to ecoinvent electricity production datasets, also with the help of the category breakdown provided in the document of the residual mixes. The residual mixes were implemented on the same voltage levels as the electricity market mixes, and the residual mixes also include the same inputs for infrastructure, emissions, and losses as the electricity market mixes. The European attribute mix itself is modeled in separate datasets and linked to the residual mix datasets for better segregation of the two concepts. For example, the Danish residual mix, here shown in ecoquery, you can see that almost 70% is coming from the European attribute mix, here shown in the activity link. The dataset for the European attribute mix itself is, as said, a melting pot of electricity producing activities from all surplus countries, here shown with an input of heat and power generation from Lithuania. It does not contain any infrastructure or direct emissions, as it feeds into the markets where these are already accounted for. The adaptation in ecoinvent also takes imports from countries outside the calculation area, EU28, Iceland, Norway, Serbia, and Switzerland, into account. These are added as electricity producing activities to the inventory, here in the example of Greece importing electricity from hard coal from Turkey. Also, the electricity mixes are included in all attributional system models, cutoff APOS and EN1504, and are also added to the Scope 2 and 3 Excel file provided via ecoquery, soon to be also released for version 3.9. An introduction to this file was also featured in the webinar on the introduction of the electricity sector available on YouTube. The last update we performed for version 3.9 was an update on the cadmium telluride photovoltaic datasets. The update concerns the datasets photovoltaic laminate production CDTE, and the data was provided by the company First Solar, and its inventory is based on data from 2020. The previously existing geography of Germany was deleted as its production has ceased in the last years. However, new production locations were added for Vietnam and Malaysia. The US dataset was also updated, and the global dataset was recalculated. In the new datasets of US, Malaysia, and Vietnam, location-specific data for both materials used in production, as well as emissions, water use, and electricity consumption are included. Internal recycling of materials is also considered in the inventories. With this topic, we are at the end of all updates for version 3.9 of the ecoinvent database regarding the electricity sector. I hope we were able to give you an overview of what has changed in this version, and of course we invite you to explore the data yourselves. For the next couple of minutes, we will have a short Q&A session and try to answer as many questions as possible that have popped up during the presentation. Please also feel free to still post some questions, and do not be disappointed if we do not answer your question directly here in the webinar, as all questions that are not tackled will be followed up via email after the webinar. I see one question, which says the amount of each transmission line, aerial, subsea, and subterranean is the same for each region where included, or is it specific? The amount is specific to the country where the specific data was available in the statistics. So also this split does not exist for all countries. So, but for all countries where it was delivered by the data source, we included it, and they are all different. And yes, Pablo, when no data was available, we used averages of continents or similar countries to approximate to make a better guess of the country. And how are import-exports accounted in the calculation of country-specific residual mixes? The imports of outside the calculation area, so if they are inside the calculation area, they are taken into account in the base mix of the country. If they come from outside the calculation area, so outside the EU, they are specifically mentioned in the data set as an electricity producing activity from this importing country. To the questions on exports, they are always calculated to the so in the end only imports are accounted, but how to say, in the end the net electricity exchange is taken as the import from one country to the other. So if there's like a bidirectional exchange, only the net electricity is counted as an import. I'm not sure I understand the question on the Norwegian example correctly. There, the final, I assume you're referring to the residual mix. Yes, the final consumption was 109 terawatt hours, and this had to be filled up. Exactly. So in the end, the final residual mix has to match the volume of untracked consumption. So that's why 96 terawatt hours have to be added from the European attribute mix to the domestic residual mix. Okay, it seems that. I hope this answers the question. Perfect. It seems as there were no more questions popping up, that we can close the Q&A session. As mentioned, if there were unanswered questions, we will follow up via email. And again, if you're interested in further updates for version 3.9, please also consider joining the upcoming webinar on the oil and gas sector. And for now, thank you all for joining the webinar, and I wish you a nice day. Goodbye.